We will walk through building a comprehensive mood tracker page. And this page will allow users to track their mood, enter journal entries, and keep track of various daily metrics, such as sleep, diet, and activities. By the end, you will have a functional and user-friendly application component like this one. This one is for this date, which is Friday, July 26, 2024. And you've got all the emojis, and you've got some other entries. We'll begin by importing essential libraries that will help us create the mood tracker. These include React hooks like useState and useEffect, which manage the component's state and side effects. We'll also use useParameters or useParams from React Router DOM to retrieve the date from the URL and Axios for making HTTP requests to fetch and save data. Lastly, we import our CSS file to style the component. In this part of the code, we start by using the useParameters hook to extract the date from the URL. We also define useState here to manage different parts of our form, such as the user's journal entry, mood values, and daily trackers. Also, this part. And I'm just going to draw your attention to these two lines of code because they are particularly important as we initialize the mood values and mood weights states. Here we use the reduce function to efficiently create an object that holds the mood data. This allows us to dynamically generate keys for each mood and assign them an initial value. The next slide will clarify how the reduce function works, helping you understand why it's used here to initialize our mood-related state variables. First, in the simple example, reduce is used to sum up an array of numbers here. The function takes two main arguments, the accumulator ACC and the current value val here. The accumulator stores the result as it gets built, while val is each number in the array. The process starts with an initial value of 0 here. This is the initial value, which is explicitly provided as the second argument to reduce. As reduce iterates over the array, it adds each number to the accumulator, resulting in a final sum of 6. We shift to the Mood Tracker app, where we have a list of moods. The list includes mood names, opposites, and associated emojis. Our goal here is to create an object, mood values, to store a value for each mood, starting at 0. To achieve this, we use reduce. On the list of moods, the accumulator starts as an empty object. Here, which is shown by bracelet, which is the initial value provided to reduce. As reduce iterates through the moods, it adds a key value pair to the object for each mood, with the mood's name as the key and 0 as the initial value. The process results in an object where each mood is set up to track its value, fully ready for users' interaction. Starts like this, and it keeps going and growing. Here's the final function. Here's the final object. A quick quiz. What does this useState hook do in a React component? The options are renders HTML elements, fetches data from an API, manages and updates the component state, handles user events. Give you a second to answer, and the answer is manages and updates the component state. Here we are looking at how to fetch data from the backend when the component lands. We are using the useEffect hook to achieve this. UseEffect is critical for performing side effects in React, like fetching data when a component first loads or when a specific dependency changes. In this case, the date parameter. First, let's examine the code at a high level. The useEffect hook wraps the fetch entry function, ensuring that data fetching is triggered each time the date changes. This ensures we load the correct data based on the select date. And now let's look at the fetch entry function itself. This function is asynchronous, meaning it will handle operations that take time, like fetching data from the backend, without blocking the rest of the application. Within this fetch function, we have this try block. And what do we do here? So the try block is where the action happens. We use axios.get to send a request to the backend here. And this is our backend. And the URL we are hitting is dynamic, constructed with the current date to fetch the relevant mood tracker entry. So if the response comes back with the status of 200, indicating success here, then what would happen? We extract the data from the response. We then use the data to update the status using set form data. Notice how we handle each field providing default values like empty strings or zeros to ensure our form is properly populated, even if some data is missing. So you can see for journal entry, for example, we've got empty string, and for mood values and mood weights, we've got empty bracelets. And those are the default values. So either we extracted from the data or we have this default value. So this is when the response is 200, and what if something goes wrong? That's where the catch block comes in. If the fetch fails for any reason, we log an error message to the console, helping us diagnose issues during development. So this is where we do the logging. But we are sending the logs to the console here. And this process ensures that every time our component loads or date changes, the app is ready with the latest data from the backend. So the moment that the date has changed, then the data is extracted from the backend, keeping the user experience smooth and consistent. So in order to understand this a little bit better, I've got a very simple example. In this example, we are tracking the user's mood. We have two buttons that allow the user to set the mood to either the happy or sad. Whenever the mood changes, we want to update the message to reflect that change. That's why we've got this use state, which defaults to happy for the mood. And then we've got use state, which defaults to an empty string for the message. And then we've got this use effect that is wrapping the set message function or the set message thing here. And the dependency array here is the mood. What it means is, so this set message will set the message to whatever the mood is. Like whenever that would change the mood, then we set the message and we reflect that change. And so this use effect is actually related to those clicks on the buttons. So whenever we click on the happy button, then we get this happy mood, send it to the use effect or set message, and then we can set the message to your mood is now happy, or the other way around. Okay, what happens in this code? First, during the initial render, the component displays the mood options and an initial message, which is empty at first. The buttons are set up to allow the user to choose their mood. Then when the user selects a mood change occurs. At this point, the use effect hook comes into play. It detects a change in the mood state and updates the message to reflect the new mood. Okay, before I move on to the quiz, I just want to point out two very key points. The key points are the dependency array, which was mood, which is very crucial because it ensures that the effect only runs when the mood changes. This is what makes the use effect hook so efficient. It only triggers when it needs to. Although not used in this example, but the cleanup functions are another important aspect of use effect. If your effect involves setting up subscriptions or timers, for instance, a cleanup function can be returned from use effect to handle resource cleanup when the component unmounts or before the effect runs again. So here's a quick quiz to test your understanding of use effect. The question is, when is the use effect hook called in a React component? And you have 4 options. I'll let you read. Okay, to answer this question, remember, use effect is designed to run not only when the component first renders, but also when specified state or props change, depending on the dependency array. All right, in the previous slides, we talked about use effect, and how we reflect the changes when we select a date. So imagine we selected a date, and then you can see that this date is selected. This is done by user effect. And now we have some inputs here. We've got these sliders here that we can change. We've got these weights here that we can up and down. Or we've got some of the entries here that we can change. And now we want to see how we reflect those changes in our input sliders, weights, and what sort of functions we have. This is what we're going to discuss about in the next slides. We have a function called handle slider change. This function updates the mood value as part of our form data state. When a user adjusts a slider, handle slider change takes two arguments, name here and value there, name and value. So the name of the mood being adjusted and the new value of the slider. So those are the arguments. So this function that actually uses the set form data function to update the state by merging the new value into the existing mood values object. So this rev data is actually the existing ones that we're copying here, and then we've got the new values here. This way we make sure only the mood values that change is updated, while the rest of the state remains intact. And then we've got the other function, which is handle weight change. This function is similar but updates the mood weights object instead. It passes the value from the event to an integer and updates the mood weight state in the same manner. So we copy all the previous data, and then for the mood weights, we copy all the mood weights here. But for that particular event that we have the update, we're going to pass it into integer. So we make sure that all the data remains the same, but the weights that we're changing will be reflected here. I have a simple function here. In this example, we define the initial state using the useState hook, as you can see it here. And then we've got the happy and motivated. This is a very simple one. So the form data state starts with default mood values for happy and motivated. And we also have the handle value change function here. This function is used to update mood values in the state. When a value changes, handle value change is called with the mood name and the new value from the event. A user sets form data to create a new state object with the updated mood value. So here you can see that we use set form data. And it's exactly the same as before. We copy all previous state properties here. And then because all the other properties remain the same, the only variable that is changing is mood values. And inside the mood values, there's only one event with its name that is changing. So we copy existing mood values here the same way as we did here. And then we update the specific mood value in this line. So we see how the state evolves here. And then you can see initially we have, this is one example how it works. Initially the mood values are happy at 80 and motivated at 30. After a change that happened with a user click or user input, the value for happy remains the same, so we want to copy that across, while the value for sad is updated to 55. In this part of the code, we retain a JSX structure that includes a div with class app container and mood tracker. So this is our return. We've got two nested divs, app container and mood tracker, and we're going to fill this part very soon. So the only part that you have to know is we've selected the date, and this is our date. So before going to the next slide, I'm going to go back to the application and show you the application. So there's like a few points that you have to know. Like, for example, when we go on a slider and we hover over the slider, you can see there's a number here showing up. This is a number, and I'm going to not hover over it. I'm going to leave, and you can see the number appears. So the number 26 appears and disappears. So this is something that we have to take care of in the next slides when we actually grab those information, or when we render those sliders. So the material that we're going to discuss about is the way that we render our sliders. We use the moods array to dynamically generate sliders for each mood. The map function here, as you can see, it iterates over moods. It iterates over the array. And where each mood has a name and emojis. For each mood, a slider is created with a range input and an emoji representing the mood. So with the name and emojis. And you can see it here. And then next we have the hover functions. Let's look at those ones. When the user hovers over a slider, the onMouse enter event sets the hover mode in this line. And the onMouse leave event clears it in this line, as you just saw in the previous slide. This hover state is used to display the current value of the slider. And then we'll go one step forward. We have this input here, and then we've got the type, we've got the ID, which is the name. We've got the min and max of the slider that varies between 0 to 100. And then we've got the interesting part, which is value and on change. So the value of the slider is controlled by form data.mode values, and changes are handled by handle slider change. So this way we'll make sure that the slider's value reflects the current state and updates accordingly. All right, now we have the last part of this code snippet. So we've got a condition here. If hovered mood equals name, then we use, for the slider value, we're going to use mood value for that particular name from the form data. And if that doesn't exist, we're going to default to 0. So this is how we set the values of these sliders here. I'm going to review map function here. Map is used to transform one array into a new one. We've got a really good example here. So we've got 1, 2, 3, which is an array, and then we double each element of this one, 2, 4, 6. That would be the result of map. Then we had another example in our mood tracker page. So we've got this array, which shows the moods with the names, opposites, and emojis. And then when we map over them, then we get each of these elements of the moods array. And then we can do all sort of things with them. For example, here you can see that we'll grab one element with its name, and then we'll set the values and on change and so on. So I'm only showing left emoji here, right emoji, and mood weights are actually skipped here. So finally, we have the save entry function, which is an asynchronous function. And why do we have this? Because when the user enters the data here, then we've got a save button that it saves or stores the data into our database, into the backend. So the handle save function in this code snippet is responsible for submitting the form data to the backend. It uses Axios to send a post request with the date, journal entry, and other form data. This is where we send the post request. And if the request is successful, the user is alerted that their entry was saved. So we had this try and error, or if and else. So if it's successful, okay, its entry was saved. And if there's an error message is logged and displayed. And let's go back to here and change one of the things. We change the sleep to 8 hours, and we click save. And you can see entry saved successfully. And then in the next slide, you can see, so when there's an error, obviously, we're just going to log an error to the console. And then there's this in our div. We've got the save button included in a container and triggers handle save when clicked, ensuring that the user's input is properly saved. So this is where it's included. So, time for an assignment. Your assignment involves creating a new feature to calculate the overall feeling based on mood values and weights. So first, create a component named overall feeling that receives mood values and weights as props, and it should return a div with a header, a paragraph, and a button. And then add a state variable called overall feeling initialized to 0. Implement a function to compute a weighted average of mood values and weights. Update the overall feeling state when the button is clicked. And for the rendering part, display the overall feeling state inside the paragraph and add an on-click event to the bottom to trigger the calculation. And the last part, import and render overall feeling inside the app component, passing mood values and mood weights as props.